If you look around at, the most impressive modern buildings today, think of a gleaming downtown tower or even just a really sleek home renovation. You
Yeah.
see this one recurring theme, right? Maximum transparency. We want light. We want these incredible views, and we want the structure to almost disappear.
Mm.
For decades, though, the materials we used, heavy steel, cumbersome wood, they just couldn't do that. They were bulky, they needed these huge foundations, and they really limited how much glass you could use.
And that gap between what architects wanted to build and what the materials could actually do. That's exactly what we're diving into today. Our focus is on the innovation that really solved this problem: aluminium glass profiles. And this isn't just a simple frame, it's a whole system, a revolutionary one that lets structures be strong, incredibly light, and also very elegant all at the same time.
Okay, aluminium glass profiles. It sounds a bit technical, but you're saying this is the key piece to getting that seamless, minimal look we see everywhere.
It is. It's the backbone.
All right, so let's get a clear picture here. For anyone who's not familiar, what exactly is an aluminium glass profile?
Okay, so at its core, it's a high-grade framing system. It's designed specifically to hold large, heavy glass panels with as little visible structure as possible. But the real distinction, the thing that makes it all work, is how it's made. These aren't just molded pieces of metal. They're created using a process called extrusion.
Extrusion. Okay, unpack that for us. What does that mean?
So extrusion is where you take a hot billet of aluminium alloy and you force it under immense pressure through a die. And this die has a very specific, often complex cross-section. This process lets you create these incredibly intricate shapes with, internal voids, interlocking parts, all with these super tight tolerances.
Things you just couldn't do with other materials.
Exactly. You couldn't achieve that economically with, say, rolling steel or milling wood. And that process, that precision, is what really defines modern versatile design. It's why these systems are the hallmark of contemporary construction.
That makes so much sense. So the way it's made is key. The precision in the manufacturing directly leads to the precision you see in the final building. So our mission in this deep dive is to really synthesize why architects and builders lean so heavily on these extruded profiles. We're going to get past the basics and understand the technical edge that makes them such a dominant choice. Let's start with the most obvious appeal: durability and structural strength.
Let's talk performance then. Because what you get is a very contemporary finish, but it's paired with remarkable longevity. When you're evaluating building materials, you have to look beyond just the initial price tag. You have to consider the whole life cycle.
Okay, but I often hear aluminum described as lightweight. And isn't that a bit of a double-edged sword? I mean, when you're talking about the outside of a building, it's getting hit with wind, pressure, potential impacts. You'd think you'd want bulk. You'd want mass, right? Traditional steel definitely gives you that. So how do these slim profiles make up for being so lightweight?
That's a great question, and it's where the physics of the material really comes into play, along with that profile geometry we just talked about. Aluminium has an exceptional strength-to-weight ratio.
Okay.
Its density is much, much lower than steel, which right away reduces the load on the building's main structure, and that can mean lighter, less expensive foundations, but the strength comes from the design that extrusion makes possible. These slim frames use things like internal webbing and really precise material distribution to maximize their stiffness. That's how they can support huge multi-pane glass units without looking bulky or compromising stability when the wind picks up.
So the engineering solves the strength problem. Now, what about the other big issue with exterior materials? Maintenance. Wood needs constant treating. Steel needs rust prevention, painting.
And that low maintenance aspect, that is a massive financial win over a building's, 30 or 40-year lifespan. Unlike steel, aluminium naturally forms this thin protective oxide layer.
So it protects itself.
Exactly. It resists corrosion and rust. That means no regular painting just for protection. And of course, unlike wood, it's completely immune to pests like termites. You're just dramatically lowering the total cost of ownership over time.
And the sleek look isn't just about the metal itself. It's also really customizable. We've mentioned the flim frames letting in more light, but what about color and how long the finish lasts?
Design flexibility is, it's paramount. And these profiles enable that seamless, modern look because of their minimal sightlines. As for the finish, they can be treated with methods like anodizing or, more commonly, powder coating. And powder coating, for example, isn't just for color. It's a really durable, high adhesion layer that boosts resistance to abrasion, fading, and any further corrosion. It basically seals the metal and ensures the look lasts as long as the structure does.
That combination, lightweight strength, low maintenance, total aesthetic control, it makes sense why we see them everywhere now, in both commercial and residential spaces. So if we connect this to the bigger picture, where are architects really capitalizing on these benefits the most?
Architectural aluminum extrusions have really become a defining feature of contemporary design. If you look at the commercial sector first, they're absolutely essential for creating interiors that are adaptable, open, and filled with natural light.
I'm thinking of those big Class A office buildings, where light and flexibility are like the ultimate premium features.
Precisely. They are the absolute backbone of interior fit-outs. You see them used for office partitions, modular walls, showrooms, and especially in high-end storefronts. And for the building's facade, aluminum gives you not just the transparency, but the structural integrity and weather resistance you need to clad a modern high-rise.
Hmm.
The ease of assembly is a huge benefit there, too. It can really cut down on project timelines.
And how does that translate into the home? It feels like they're what makes that indoor-outdoor living style even possible.
Oh, absolutely. In residential design, they enhance modern spaces by allowing for these enormous sliding and folding doors, glass walls, balcony enclosures. The slim profile means the glass, not the frame, becomes the visual focus.
You brought up the manufacturing precision earlier. What if an architect is designing something totally non-standard, like a curved wall or a massive panoramic window? How flexible are these profiles?
They're entirely tailored. The extrusion process means you can create dies to fit pretty much any design requirement, no matter how complex the layout is. So whether you're talking about a small internal office divider or, a 10-meter wide panoramic window, that customization ensures a perfect precision fit. And that's so critical for a seamless installation, especially where different materials meet. A polished architectural look relies on that perfect fit.
The customization is clearly a huge design win. Okay, let's shift gears a bit. I want to talk about the real technical demands of a building envelope, because here's where it gets really interesting for me. Aluminium is a metal, and metals are great conductors of heat. So doesn't the very nature of this material kind of undermine a building's energy performance?
That is a crucial point, and it's one that the industry has decisively addressed. We have to talk about something called a thermal break. While aluminum itself is conductive, yes, the high-performance profiles integrate a sophisticated insulating material, usually a polyamide strip, right inside the profile's cross-section.
So you're saying these insulating strips literally break the metal-on-metal contact?
Yeah.
From the outside face of the frame to the inside face?
Exactly. They dramatically reduce the thermal transmission right across the frame. This one innovation turns what could be a thermally inefficient conductor into a highly effective insulator. It minimizes heat loss in the winter and reduces heat gain in the summer. This is absolutely essential for meeting modern energy codes.
That makes the whole system viable anywhere in the world. And speaking of viability, let's talk about the glass it holds. What kind of performance can you get?
The profile's versatility means it can support a huge array of glass types, so architects can hit very specific performance targets. This includes simple, single-pane glass for partitions, tempered glass for safety, laminated glass for security and sound, all the way up to high-performance double or even triple glaze units for superior thermal insulation.
And for soundproofing or high insulation, the thickness of that glass matters a lot. What's the typical range these frames can handle?
We're typically looking at compatibility from, say, 4 millimeters all the way up to 24 millimeters thick. And that huge range lets builders choose the exact glass they need for, say, intense noise reduction in a city center, or for top-tier insulation in a really harsh climate, all without changing the visible look of the profile.
We touched on corrosion earlier, but let's go a bit deeper on climate resistance. What if you install these in a coastal city with salt air constantly eating away at metal? Is that natural oxide layer enough?
Right. Coastal areas are the highest risk, no question. It's because of the chloride ions from the sea salt. And while that natural oxide layer offers some initial protection, in those situations, the finish is absolutely critical. You need a high-quality marine-grade powder coating or a very robust anodizing treatment. These create a thick, impermeable barrier that stops the salt from starting any galvanic corrosion. It ensures the profile keeps its structural integrity and its looks for decades, even with constant moisture and salt spray.
So the coating isn't just a nice bonus, it's a critical engineering step in those environments.
Hmm.
Okay, that technical stuff provides great context for why these are chosen. Let's pivot now to the more practical side for our listener. Installation and maintenance. What does the installation actually look like?
Installation demands precision, but the process itself is very standardized. First, you get precise measurements. Then the pre-cut aluminum sections are assembled, usually with corner brackets that lock the frame together. Then you secure that frame into the building structure itself.
And then the glass goes in.
Right. The glass panel is carefully inserted into the frame's channels. It's held securely, but it's also cushioned by these rubber or EPDM gaskets. They're sort of the unsung heroes of the whole system. Finally, you seal all the edges with a high-grade silicone sealant.
Yeah.
The hardware, the gaskets, screws, brackets, sealant, they're all essential for stability and weatherproofing.
So if you're managing a project like this, what are the most common and probably most costly mistakes people make during installation?
Mismanagement in two key areas can just ruin the whole system's performance. First is sealing. Poor sealing means water gets in. That leads to internal damage, maybe even mold. The surface has to be perfectly clean before the sealant goes on to guarantee it sticks. Second is securing the frame. If you over-tighten the screws, especially in the corners, you can stress the aluminum or even crack the glass panel. It compromises the whole unit.
And once it's installed properly, what about that minimal maintenance you promised?
It really is minimal. Aesthetically, just routine cleaning with mild soap and a soft cloth is all you need. The main goal for long-term maintenance is just prevention. Check for any loose fittings now and then and inspect the gaskets.
Why are the gaskets so important to check on?
Because gaskets are a wear item. Over time, UV exposure and temperature changes can make them hard or brittle. If they look worn, you have to replace them right away. They're the primary barrier stopping dust and water from getting into the frame system. A little bit of simple upkeep ensures these things perform for decades.
Okay, moving to the bottom line, cost and sourcing. We know quality affects the price. Let's ground this in a real-world example. If we look at a market like India, what's the typical price range and what really separates the high end from the low end?
Well, based on market data, the cost in a major market like India typically ranges from around 300 to 1,200 rupees per meter.
Oh, that's a huge range.
It is, and it reflects some really critical differences in quality.
So what should a buyer be looking for that justifies spending, 4 times as much?
You're paying for the alloy grade and the profile thickness. The more expensive profiles use higher grade, more corrosion-resistant alloys, and they have thicker walls. Thicker walls mean more strength, more fatigue resistance, more longevity. You're also paying for the quality of the finish. A premium anodized or high-grade powder coat is just going to stand up to the environment better.
And when you're sourcing, how can you make sure you're getting a quality, structurally sound product no matter who the supplier is?
Always prioritize products that meet recognized standards. In global markets, you'd look for ASTM, that's the American Society for Testing and Materials. In India, you look for IS, the Indian standards. These certifications guarantee the material's composition, its strength, its corrosion resistance. A good supplier will always provide the data sheets and have verified warranty terms.
So what does this all mean? We started out by talking about this modern architectural dream. Maximum light, minimum structure. And it seems what we've synthesized is that aluminum glass profiles are really the elegant solution to that puzzle.
They deliver this potent mix of strength and style. They're durable, they're low maintenance, they're infinitely customizable because of that extrusion process. And with innovations like the thermal break, they offer amazing technical performance. They're just the ideal tool for architects who want to create those open, light-filled spaces that still meet really tough modern energy and structural codes.
And the relevance for you, our listener, is that once you understand these features, you can look past the glass and really appreciate the sophisticated engineering that defines every modern building you see, from a glass partition in a lobby to that huge sliding door in a home. This technology isn't just framing glass, it's really redefining the quality of the space we live and work in.
Exactly. And what's fascinating to me here is how the ability to hold these huge glass panels with such slim frames, it doesn't just enable a certain aesthetic. It fundamentally redefines how we experience space and light and even nature in our built environment. I mean, think about it. We just accept this level of transparency as the modern standard now. A generation ago, windows were small, frames were deep. And, it raises an important question. What fundamental structural limitations in architecture are we still still trying to eliminate, maybe with materials and systems we haven't even fully adopted yet.
A perfect technical and philosophical thought to mull over the next time you're gazing through a beautiful, structurally sound, and highly efficient window. That's all the time we have for this deep dive. Thank you for joining us.